All I'd do is just give a historic overview of the lake management issue in Canada, in Alberta. I've got some fairly strong opinions on where we're at and why we're here, but it is like a family reunion. I think I gave my first talk on lake management in 1976. Yeah, so, and there's a message there. We have lights off, you have lights on. Okay? Anyways, there's actually a tremendous legacy of scientific research in Canada and in Alberta on this topic, and work continues. That's not the issue. The issue is who's responsible for implementing all this great scientific knowledge we have, and I'm going to try and illustrate that in a constructive way for you. To sum it up, I guess my opinion is I think we know what to do. It's a question of who should have the leadership and who's going to take responsibility for managing these lakes. I view it as a policy gap, a significant policy gap in Alberta in terms of how we manage our water. We manage our rivers fairly well. I'll give you an example of that. Our lakes have been extremely well studied, but essentially not managed to the degree that they should have. And that's why this topic is recurring. So I view this as a political issue, a policy issue, to a much lesser degree a science issue. Okay, so I'm going to give you 5 slides on NSWA. First of all, NSWA, most of you are familiar with it, but just quickly, we're one of the 11 WPACs in Alberta. We're a nonprofit society. We have a membership of organizations and individuals. I'd like to introduce some of our staff who are here today. Melissa Logan, Melissa, raise your hand. Alyssa Wesselson, Billy Mulholland, I saw Billy, and is Eleanor here? There's one more lady coming, so feel free to talk to any of the staff members about the content of this talk. Our job as a WPAC is to provide Our job is to provide information and advice on watershed management. So we're working variously at the scale of the North Saskatchewan River, or at sub-basin scales, or in this case, at individual lakes. The science and the policies are much the same, and the challenges are similar. Our offices are provided by the City of Edmonton, and we operate on a budget of under $500,000. We get $250 from the province, and we get about $250 from municipalities. We have all the multimedia stuff going, so lots of information on our website. I mentioned there's 11 WPACs. Again, you're probably familiar with it. These WPACs, Watershed Planning Advisory Councils, have been in place for about 7 or 8 years now, some younger. We're all working together. And it's basically trying to fill that gap in terms of watershed management and watershed planning and management. It's been a long time coming in Alberta. WPACs are trying to fill that void in a voluntary way. It's a voluntary model, so it's a little tough that way. Other places like Ontario have conservation authorities, which have been in place for quite some time, since the late 1940s, and they have an entirely different mandate. So there's some things we can learn, I think, in Alberta about this watershed management business. Okay? And our publications over the years have involved descriptive, historical work, planning advice, and an excellent municipal guide that's available on our website, the State of Watershed Report. And then there's many technical reports. We're trying to, again, fill that gap in watershed planning. So you're looking at land and you're looking at water. So we've done a lot of water science work as well, some economics. So it's a professional, we're approaching it from a professional water planning point of view. So all the information's there. And the culmination of it last year was a couple of big plans, the Integrated Watershed Management Plan for the North Saskatchewan River, which is a really high-level document, just kind of points the direction that we all need to go. And a similar one for the Vermilion River, which is our first sub-watershed plan. And also at the bottom left, there's an atlas, an educational document we produced. There's 3 we brought in for door prizes today that Mrs. Nielsen is holding up. So it's a really nice summary of land use and the natural condition of the North Saskatchewan River and human impact. Okay, I think that's enough there. So on to the North Saskatchewan Basin. It's a pretty big piece of real estate, lots of issues, fairly high population, we have about 1.2 million people, most of whom live in the capital region, about 1.1, so the extended population is fairly small. We have lots of industrial activity in terms of resource development, increasing urbanization, and of course, increasing demand on our lake resorts. We have about 37 recreational lakes in the basin, and we really don't have management plans for any of those. We're pretty close to the sturgeon. We're actually, I think, over the hill here in the west. But at the sub-basin level, you'll be hearing later today from Leah Comsrud in the city of St. Albert, and we're proposing to look at the Sturgeon River watershed as our next sub-basin plan. And as you're aware, sturgeon includes some very important recreational lakes. Okay, so now on to lakes. Lakes in Alberta are quite unique. The landscapes are quite unique. There's different geology here, so if you come from BC or Ontario or northern Manitoba, you're probably used to a very different type of lake. There's been a lot of research in our lakes here in the prairies, in the parkland and forest area. They're very, very fertile lakes. They're naturally very fertile. They tend to be very shallow. They tend to be poorly flushed, which is a huge thing for lakes. So lakes, use the word stagnant, but the flushing rates in these lakes is generally quite low. So as we've settled the province and built our farms and summer villages and sometimes industrial activities in our watersheds, we've impacted these lakes in a very unique way. Because they don't flush, a lot of the materials that have been freed up by our activities on the land surface have gone into the lake and stay in the lake. And specifically, we'll talk about phosphorus most of this presentation. Phosphorus is the key to plant growth. It's the key to fertility in most of our lakes. Probably the driving factor. There are other factors, but phosphorus is very important. And a lot of things we do in watersheds drives phosphorus into the lake. And once it's there, it's incorporated into the bottom sediments, and it's a problem. We have continuous population growth. We all know what the economic forecasts for the region are here, so we have to be prudent, and we have to get after this question of our lakes. We've done a very good job in managing our rivers in central Alberta. I'm going to show you a few examples of that, but our lakes languish for lack of management. We're going to have a lot more pressure on the shoreline and in the watershed. One thing that I've often pondered is why we haven't explicitly looked at the value of our lakes in terms of the recreational economy. If you look at some of the big lakes like Sylvan and Pigeon and Wadman here, tremendous real estate investments, tremendous economy generated by boating, fishing, and services. And it's never been, I think, properly quantified. I think the value of the lake-based economy, recreational activities is quite enormous. And you can do the math yourself in some of our big lakes. If you've got a couple of thousand $500,000 homes around the edge of the lake, Pigeon, for instance, Sylvan, you're already up into $1 billion order of magnitude in terms of the economy, in terms of the investment. So these are not trivial water management issues. These are very important to the economy of the province and to the aesthetics and for ecological reasons too. But there's a big dollar story there that I think needs to be fleshed out. And so, jumping now to some of the technical stuff, I'm going to show you a few slides, and we'll get a little bit detailed, but I'm trying to do it for a good reason. This whole business of phosphorus and managing fertility of lakes is not new. It's some of the driving work was done in the 1960s in Europe. And the reason was, in fact, in Europe and in North America, I think we hit our pollution low point in the 1950s and 60s. We had growing population, very poor pollution control. In Western Europe, large populations relying on small reservoirs for drinking water. And particularly in Germany and Austria, France, there was a lot of research trying to understand why are these reservoirs so green. And so a lot of work was done through the OECD, okay? The Organization for Economic Cooperation and Development. And they supported some high-level research, and the main initial milestone was a report by Dr. Ballmeuter, and it was released in 1968. And he basically took a look at reservoirs and lakes and put together a model that showed how each lake is a character or reflection of its watershed. Scientists had known this for a long time. What he did is he put the numbers to it. So he related phosphorus loadings from agriculture, from municipal discharges, from industry, to the hydrology and depth of the lake, and came up with a model to predict the condition of the lake. So it was a pretty important milestone in work. And I'll just show you the equation here. This is the only equation for today, so you don't have to worry about it too much. But it just says you can predict total phosphorus. On the left side, total phosphorus concentration of the lake is a direct function of L, which is the loadings from all sources, and in the denominator, the mean depth and flushing and sedimentation characteristics of the lake. Every lake is different. Those numbers are different for every lake. We put this out there, and the equation works. And the equation has been modified many times over the 70s and 80s. And some of our new computerized water quality models for lakes still rely on this basic mass balance. It's a basic mass balance if any of you folks are engineers or chemists. So if you know what's going in, and you know how much water is going through, and how deep the lake is, you can predict pretty well what the phosphorus concentration of the lake is going to be. And if you can predict that, you can say a lot about algal growth and a lot of other conditions. So during the 1970s and 80s worldwide, there was a huge amount of applied research looking at how to manage phosphorus and looking at all the effects of phosphorus enrichment on lakes. So there's a ton of information. Okay? And the culmination was what we call like a modeling approach, a modeling sequence. Again, if you know what's coming into the lake, you know something about the morphometry and the flushing of the lake, you can predict the phosphorus concentration of the lake. If you can predict the phosphorus concentration, you can predict the amount of algae. So it's, you know, it's not an imperfect modeling sequence, but it's been proven. So it's a bit technical, but I just want you to understand that that stuff exists, and it's existed for a long time. So this is, if you guys remember, the older people remember Ed Olashuk, who was the editorial cartoonist for the Edmonton Journal. Yeah. So that was February 13, 1970. So the official's got a sign there, it doesn't say add phosphorus, it's ban phosphorus. Point being that by the late 60s across Canada and the States, and Western Europe, tremendous buzz about phosphorus, about lakes dying, about the need to do something. So, you know, a lot of us in the room went to university in the 60s. We got trained in that then. So it was certainly topical in the press. It was the top of everybody's mind. Those of you who are familiar with Ontario, Lake Erie was supposed to be dead. You know, you've all heard that. Tremendous algal growth. So following all this, there was a real push of pollution control in Canada and in Alberta, and looking at specifically removing phosphorus in municipal wastewater. So the Great Lakes, Ontario built all kinds of advanced sewage plants, and we did in Alberta as well. Okay, so I'm going to talk about Alberta here. So for the North Saskatchewan River here, you know, all our water, most of our water is generated on the east slope of the Rockies, precipitation, snow melt. And we have a couple of big reservoirs. That's the eastward view of Lake Abraham, Bighorn Dam. Okay. And on the map there, you'll see the two big reservoirs, the Brazeau and Bighorn. And they're hydro dams. They were built in the 50s and late 60s, and became operational in the early 60s and early 70s. And they've forever changed the flow of water in our river. Okay. That's the Brazeau. Most of you will be familiar with this. And the next one. And the Bighorn, the next one. And the story, you probably won't be able to see it, but what happened was in the 1950s, there was huge concerns in the city of Edmonton about pollution of the North Saskatchewan River. Our population was up around 300,000. Wastewater plants were taxed. The river in the winter went through a very low flow cycle. So when the proposal came along to build these hydro plants, the city of Edmonton was involved with the province in trying to ensure that there's good winter flow in the river so that we could manage our wastes better. So there's actually quite a good news story here. So what's happened is the hydrologists would say we flipped our hydrograph. We have higher flows in the winter and fall now, and lower flows in the summer. But those higher flows in winter were very important because the river was a mess in the 1950s. It's well documented. You very seldom hear about fish kills in the North Saskatchewan River anymore. They were very, very common. And again, pollution control was in its infancy in the 50s. Okay? So there's a lot of foresight shown by people. And then the other part of the story here deals with phosphorus specifically. I mentioned the work done in Ontario and in Alberta. Alberta led the way, actually, in municipal wastewater treatment. And specifically down in Calgary, 1982-83, they implemented the first phosphorus reduction plant technology in Alberta. And for years, Alberta got high marks in terms of how we managed our municipal wastewater from our big cities. And we did. And the reason was the Bow River was a mess. The Bow River and irrigation canals were a mess in the 1970s with the weed pool. So the advice given to the regulators in the department was to reduce phosphorus in Calgary, which they did. And then we have that same regulatory approach was applied to Lethbridge, Red Deer, Edmonton, Grand Prairie, Fort McMurray. So here, Gold Bar, 50th Street, this is a picture of the Gold Bar wastewater plant. That's gone through such a phenomenal increase in improvement in technology, taking out phosphorus at the plant through various means, and it's had a profound effect on the river. So this is what goes into the river. It's a little bar graph I got from folks at the City of Edmonton. It simply shows in the last 15, 20 years, there's a lot less going in. See how the bars drop down? That's total phosphorus load into the North Saskatchewan River from the Gold Bar plant. It's way down. It's down where it was in the 1920s. So the point is, if you apply science and pollution control, you can fix things. And so, a very good story here. What happened to the river? Well, that top line is the phosphorus plot for the river, about 100 kilometers down from Edmonton. The river downstream from Edmonton is much improved because of pollution control, because of a highly professional and strong regulatory approach to cleaning it up. And so the river has improved greatly. Next one. And it's another more complicated plot, but it's basically the same period of time. And that red line is our Alberta surface water quality objective, which is a guideline. We've really done a bang-up job on this river in terms of nutrients. So let's switch back to lakes. Okay. We'll just run through some recreational scenes here. I think you've all seen this. Okay, good. I love that. Okay. Just go through them. Algal growth, cyanobacterial growth, looping algae, are endemic. Some lakes are much worse than others. We have lots of problems as a result. We have wildlife mortality, we have fish kills, we have domestic pets that have died. We all have heard these things over the years. We have a much better surveillance system now than we did 20 years ago. But these are all reflections of the fertility of our lakes. Lots of phosphorus. Okay. There's Ed Olship's cartoons here. This is from May 12, 1970. We carry the latest fishing equipment. Geiger counters, mercury content meters, and phosphate level indicators. So anyways, Ed was on top of it, and we're quite interested to see this historically. It came to us 5 years ago. We found these old cartoons. So when we get down to a lake, what we're really essentially trying to do is understand how much phosphorus each individual lake can tolerate and determine an allowable load, which is exactly what we did for the rivers. We figured out the allowable loads into the rivers. Rivers have improved, generally speaking, in terms of nutrients. We can do that for lakes. I'm going to talk about this thing very quickly because this was a big deal in 1976, and I've got a speech here by Bill Yurko, 1972. Bill Yurko, he was the first minister, and he made a speech at a symposium. It's called the Symposium on Lakes in Western Canada, held at U of A in 1972. And he gave a very good speech, and he talked about enough is enough. Our lakes are in terrible condition. We can't do this anymore. And it was a very well-intended speech. But that was 1972, and we're 41 years later, and we're basically concerned about the same thing. So what he basically said, our department is going to get out and try and do the research and understand what's going on in these lakes, which we did to a large extent. Okay? And so we did some work at that piece because in the mid-70s, there was limited scientific methods available here. So we developed our lake sampling, small stream sampling approaches, lab methods, and so on. And we worked up that piece there. There was a proposed subdivision, a very common scenario. The subdivision proposed at the Narrows. People at the lake said, we can't possibly have any more development of this lake. Our lake is a mess. This is 1975. Our lake is a mess, no more development. So we were asked to develop a model the department could use to plan for lake management. That model was based on the European work. So basically, we developed what we call a nutrient budget, a phosphorus budget. We measured all the sources coming in, and have done that a number of times since in central Alberta. There's about 7 or 8 lakes that have very detailed studies. Pine Lake, Lake Isle, Lac St. Anne. Pigeon is being done now. I think Blackfish got a fairly good evaluation. And so in central Alberta, we've got a pretty good idea of a number of things that affect lakes. I'm not going to have time to go into the details here, but there's some handouts if you're interested. I think we have a pretty good idea about what comes off the land surface. It does vary, but we know clearly the differences between forested runoff and agricultural. We know that clearly. We know clearly that sewage has to be managed. We know clearly that we have something very unique in Alberta lakes, which is called the internal load or the sediment release. At the bottom of our lakes, we have many meters of soft organic sediment. A lot of phosphorus that gets into the lake is processed through the ecosystem, but eventually works its way down, and it's trapped in the lake. It can't leave the lake because the lakes aren't flushed. So what happens is it sets up an internal recycling. And in our shallow lakes, that's what happens every July and August. Basically, a huge release of phosphorus, and it's amazing. And so we've done several studies over the years to try and measure that, and it's a big deal. It's a big deal. So from a lake management point of view, we have to be thinking about no further increases in phosphorus loadings to these lakes, because they can't handle it, they can't deal with it, it doesn't go anywhere. So for lake management planning, water quality has to be our foundation. That is the big issue that we act about all the time. So if we're talking about watershed plans, lake plans, we've got to have that water quality management thing right in the middle, and then that'll relate to phosphorus loadings, and that should be related to your development policies. Making that last connection is the trick. But we can absolutely develop a critical load, an acceptable load for Mayatan or Wadman or Pigeon. I'm generalizing now, but I believe we can do that quite well. It's translating that number, into planning and development guidelines. So that's a challenge. So think of a medical analogy. You've had your blood pressure checked, you've got an issue, you're on a salt intake low. You don't cut salt entirely, but you have it limited according to your body. It's the same thing for lakes. We can figure out technically the phosphorus capacity of each of the lakes. So that's a sediment from the bottom of the lake. We did a lot of work in the late 80s and 90s. That's a typical, the blue line there is really typical of a shallow lake in central Alberta. By the time you get to July or August, phosphorus just takes off. And the algae should take off as well. And a lot of that is from that internal store. Just put a bunch of pie charts here. Okay, so that's a little lake north of Bonneville called Tucker. The purple on the left is the internal load, 60%, and there's over 59 of the total loading going externally and internally. The internal load is 60%. And that is an amazing number because it shows up in a lot of these lakes at that same percentage. So next one, Wadman Lake, Pat Mitchell did this in the early 80s, it was 68%. It varies from year to year, but it's the majority. Next one, Pine Lake, Al Sozak, and I did that in 92, 60% again. This is all coincidence. Next one, next just hit that again. Lake Isle, Lac St. Anne, you probably remember there was some dogs died at Alberta Beach in 1995 and set up a big realization amongst people. we need to look at how we manage these lakes. So Pat Mitchell did a very detailed study of lake tile and waxing, and the same pie charts start showing up. Internal load is very important. Next one. Waxing in, and again, there's one more. And Gull Lake we did in 2000. So I think I'll finish there. There's lots of information. There's lots of information about how we as humans affect our lakes. The missing piece is that policy gap. And it's a serious thing because we've done such a good job in terms of the rivers, central Alberta, generally speaking, and can be applied to lakes. So what we have to do, all of us, is figure out how we take this science-based water quality approach, allowable loading for each lake, and translate that into an area structure plan.